Okay, now we're going to do some Pythagoras where we're going to figure out how to find the long side, the hypotenuse of a right angled triangle. Well, it's pretty straightforward. You use this idea that if you take the two squares, if you make squares out of the sides, the short sides of a right angled triangle, they'll always add up to the long side made into a square. So a squared plus b squared equals c squared. So if you've got two short sides, all you do is go 6 squared plus 8 squared. You work it out, it'll equal c squared. Well, 6 squared is 36. 8 times 8 is 64. You add it together, you get 100. Now you're looking for the number that multiplies by itself to equal 100. You square root both sides. The square root of 100 is 10. So that's sometimes it works out nice and evenly like that. Sometimes it doesn't. So what if you had a thing, a right angled triangle like this, where you've got 7 and 9 and you're looking for this long side? Well, you make a square out of 7. 7 times 7 is 49. A square out of 9, it's 81. And you add 49 and 81, you get 130. Then you need a calculator because you're going to, or you can write the answer down. The answer is the square root of 130, which is a bit bigger than 11. But if you've got a calculator to the nearest tenth, the answer for C is 11 is C equals 11 comma 4. Well, that's how all these questions work. You just square the two sides, add them, and take the square root. And that's Pythagoras. Question 7 is just a story with a ladder, but there's really a triangle there. You're given two sides of the triangle, and they're given in decimals, but you just square them and add them and take the square root, and that's how it works. So that's it for now. Hopefully the sound works on this one. I hope it does.